right, guys, let's look at the second activity called comparing areas made of circles. Number 1 is saying each square has a side length of 12 units. Compare the areas of the shaded regions in the 3 figures. Which figure has the largest shaded region? Explain or show your reasoning. Okay, so just like the warm-up we discussed in the warm-up, the side length of the squares, R square, is the diameter of the circle. Okay, so we need to know I had this big Okay, guys, let's look at student task statement number 2, comparing areas made of circles. Number 1 saying each square has a side length of 12 units. Compare the areas of the shaded region in 3 figures. Which figure has the largest shaded region? Explain or show your reasoning. So, we need to find the area the area of these blue shaded regions and find out which one has the largest one, okay? So we first need to find the area of a square, and I'm going to write that down to the side, area of a square. And you guys should know this is length times width, or base times height, because it's a parallelogram as well. And then the area of a circle, which is pi times r squared. Okay? So, what I want to do is I want to start labeling my side lengths, okay? And I want to find the area of the square first because I want to see what I'm taking from. Once I find the area of the circle, I'm going to subtract it from the area of the square and find out how much is left over, okay? So 12 times 12, which would give me 144 units square. And this is for the square, okay? So now I need to find the area of the circle. Now, just like we discussed in the warm-up, the side length is the diameter of the circle. So the diameter is 12. What would be the radius? If you guess 6, you are absolutely correct. So I'm going to do 6 times 3.14. And keep in mind the reason why I'm multiplying the times itself because r squared is r times r. Okay? So when I multiply 6 times 3.14, it's going to give me the area of 113 and 400ths. Okay? So, needless to say, all right, we're going to move on to the next one. I don't want to do any subtraction just yet. I want to find the area of all my circles first. All right? Now, when I move to figure B, I see that it has 4 smaller circles, okay? But they all seem to be equivalent. Now, notice that whenever I draw my diameter is broken into 2 pieces. And now, that 6 is now a diameter to the smaller circle. So, what would be the diameter of this if 6 is the diameter of the smaller circle? What would be the radius, I'm sorry about that. What would be the radius? If you guess the radius would be 3, you are absolutely correct. 3 units. So now I want to take that radius and I want to plug it in. So it's going to be 3 times 3 times 3 and 1400s. I'm sorry about that. So when I multiply that, it's going to be 3 times 3.14. And I should get 28 and 2600ths. Now, since I have a quantity of 4, I want to take that and I want to multiply it times 4 because I have 4 equal circles. I need to subtract all of their areas, okay? So when I multiply my answer by 4, I actually get 113 400. Okay, so we noticing, okay, those numbers have some similarities, okay? So now for the last one, which is figure C, that diameter in figure 1 is broken up into sets of 3, which would be 12 divided by 3, which would be 4. So now the radius that we need for the area is now 2. Okay, that's the radius. So it'll be 2 times 3.14. And guess what? If you guys really at home want to be challenged, then what am I going to multiply my answer by? How many sets of these tiny small circles do I have? If you guess 9, you are absolutely correct. So I just wanted to challenge you guys to see the bigger expression. So 2 times 2, which is 4, times 3.14, which is 12 5600. I'm going to multiply my answers by 9, and that's going to be, can you guess? 113 400. So what's going to happen when I subtract 144 from 113 400? So I'm going to write that in red at the top in this box, because all of them have the same area. All the circles seem to be taking up the same amount of space. So I want to subtract the areas now, which would be 144. Let's add 2 decimals, and 113 and 0 and 400. Okay, so I can't take away, you guys. You could, if you're using a calculator at home, that's totally fine because we're working with big numbers today. But here we go. It should be 6, 9, and then, okay, that's 0. And then it's going to be 3. The ones cancel out. So it's going to be 30 and 96 hundredths, and it's going to be units squared. All right. So all of them had the same amount of all of them had the blue shaded area is the same across each figure. Okay. So I want you at home to tell me why. Why do you think so? Explain it to me. Okay. Now, while you're writing down your explanation, you could pause the video, but I'm about to move on to question number 2. All right. So for question number 2, it says each square in figure D and E has a side length of 1 unit. Compare the area of the 2 figures. Which figure has more area? How much more? Explain or show your reasoning. So now I'm comparing figure D and figure E. Okay, they're saying that these squares has a side length of 1 unit. All right. And this is 1 unit as well. So they said we need to find the area. So let's start out by finding the area of the squares. So this will be 1 unit squared. This is be 1 unit squared. Okay. Well, if this side is 1 unit squared, this side will be 1 unit squared, not 2. Okay. So if you notice, right? If you notice, and I'll guys, I love to trace. Okay. If you guys notice that these 2, and I'm going to slide one of them over at least, it makes 2 full circles. So if I slide this over, it makes a circle. If I slide that, it's the same size. If I slide it over, it will make a circle. Okay. And it seems to be equivalent circles, right? So what would this 1 unit be compared to the circle, in reference to the circle? If you guess the radius, you are absolutely correct. So 1 would be the radius. Why? Because it's going halfway across. If we would go all the way across, it would be 2. But when dealing with area, we need the radius. Okay? So I'll rewrite the formula for you guys again. And you should know that this is R times R. So 1 times 1 times 3.14, which would be equivalent to 3.14. And then since I have 2 circles that's the same, we could multiply our answer times 2. And this will give me 6 and 28 hundredths units squared. And now I want to take the area of those 2 squares, which will be 1 plus 1, which is 2. So notice that I took the area of those 2 squares, and I'm going to add it together, and it's going to be 8 and 2800 units squared. Okay. Now let's look at the next figure. This one seems a bit more complex, but we're just going to dive right into it. All right. So figure E consists of, I don't know, some people may see 2 squares, some people may see circles. I see actually 4 squares. So this is 1, 2, 3, 4. And keep in mind that all the side lengths is 1 unit. 1 unit. And all of them can keep going from 1 unit to 1 unit, okay? So this would be 1 unit. This would be, oops, I hate that. I hate when I do that. I'm sorry about that, guys. So it's because my arm's resting on the side part of my iPad. So this is 1 unit. 1 unit. And you guys could be leaving it all to the side. But just understand that all the side lengths are 1 unit, okay? So 1 unit times 1 unit is going to be, all the areas of this square is going to be 1 unit squared. Because 1 times 1 is 1. And I'm going to erase that. So this is 1 unit squared, 1 unit squared. That's all the areas, okay? So we're starting off with this figure is starting off at 4 units squared. Because we added all those units together. Now I want to add these pieces up because these are quarter circles, okay? These are quarter circles. So when I add a 4, it makes 1 circle, and I have enough to make a semicircle, okay? So I'm going to shade it in a different color so you guys know what I'm talking about. 4 pieces will be equivalent to a circle, okay? And then this piece right here will be equivalent to a semicircle because two quarter circles make a semicircle. So I'm going to draw my semicircle so you guys can reference to it. And I'm going to draw my whole circle in green so you guys can make reference to it. And just know that I got my 4 pieces from here and I got my 2 pieces from the other side that's yellow. Okay? So one side is 1 unit. Oh, excuse that. One side is 1 unit. Okay? So this is a radius. Now, being that we're dealing with half of a circle, what do you think we need to do with our area formula? And let me just give you that friendly reminder. Area is equal to pi r squared. What do you think we need to do with that formula or add to it since it's half of a circle? If you guess divided by 2, you are absolutely correct. All right. So I'm going to bring my work to the bottom portion of this page. To the bottom in this area so you guys can see. So I'm going to have area is equal to 3.14 times the radius is 1 because the side length of the square is 1 unit. So 1 times 1. And then I want to divide my answer by 2. All right. So 3.14 divided by 2. And it should be 1 57/100. Okay. So that's for the semicircle. So I'm going to add that to 1 57/100. Okay. All right. Then the next one is the same thing, but it's dealing with a whole circle now. So we don't have to, we don't have to divide by 2 because it's a whole circle. So what we're going to do is we're going to do area is equal to 3.14 times 1 times 1. Okay, and it should be 3.14. Okay. So now what I want to do is add all of my values together, okay? Which is 4.00, which I'm adding those 2 zeros because I have decimal values, and 3.14. So when I add all of those numbers together, it should give me 8 71/100 units squared. Okay. So which figure has the more area? Explain, and how much more? So what would I have to do with these two numbers? What would I have to do with these two numbers if I want to figure out how much more? So you think about this at home. Figure E has more area, but how much more? Okay. And then I want to challenge you guys to explain, put it in your own words, because I did the part of showing your reasoning. Now I want you guys to put it in your own words of how did we figure out that figure E had the more area. All right. So you guys think about that, and I'll see you guys in question 3, which is the last question of lesson 9.